Okay, so now let us look at more examples of division of polynomials. So first we have divide p of x by q of x. So the first polynomial p of x is uh, x plus 3x square, and the second x plus 3x square minus 1, and we have to divide it by 1 plus x. So the first thing that we have to notice, we have to write the polynomial in the ascending order of in the descending order of the powers. That is, first we write x square, then the x term, and the x to the power 0 term. So the same goes with the divisor also. We write the highest power of x. In this case it is 1, x to the power 1, and this is x to the power 0. So first we arrange the terms in the descending order of powers. Okay. So next what do? We look at the first term of the divisor, and then we look at the first term of the dividend. And now we want to make, we want to find out some term. Okay, some term, so that when we multiply it with this expression or this binomial, the first term should become the first term of the divisor should become same as that of the dividend. That is, the first term of the x. Okay, so the first term of the divisor x should become the same as first term of the dividend, that is 3x square. So we have to find out some term, so that let's say 5 or 6 or 7, some number or some term, so that when we multiply it with the divisor, it should give us a term with 3x square. So the first term, the term that we are looking for is x, so that is 1x. So which number into 1 will give us 3? 3. What number into what into x will give us x square? X. So if we multiply 3x into x plus 1, we'll have a 3x square term in the dividend. Okay, so 3x into x will give us 3x square, plus 3x into x will be 3x. Okay, note that although we are checking for the first term, okay, we have to multiply for the entire term in the divisor. Okay, we finalize that we have to find 3x based on the first term x, because x into 3x gave us 3x square. Okay, so although we decided this 3x based on our first term x, when multiplying we have to multiply both the terms with this 3x. Okay, now what do? We subtract. So subtracting 3x square minus 3x square will be 0, and this 3x will become a minus 3x. Okay, minus 3x plus x, that will be minus 2x. Then we bring down the 1. Okay, so now we look at x and minus 2x. What into x will give us minus 2x? Okay, so we have 1x. What into x will give us minus 2x? So 1 into minus 2 is minus 2. X into x to the power 0 is x. So minus 2. Okay, so minus 2 into x will be minus 2x, same as the first term. Then minus 2 into 1 will be minus 2. Okay, now we subtract. So upon subtracting, this becomes plus 2x, plus 2x and minus 2x, that gives us 0. this becomes plus 2, plus 2 and 1 becomes plus 3. Okay, so upon dividing x plus 1, upon dividing 3x square plus x plus 1, dividing by x plus 1, the quotient is 3x minus 2 and the remainder is 3. Okay, now I want you to look at our divisor polynomial, that is x plus 1. What is the 0 of this polynomial? We know that 0 of the polynomial is that value of x, so that when we substitute that value in place of x, the whole thing becomes 0. So how do we find that? We first equate the polynomial to 0, then we solve the equation for x. So in this case, the 0 of this polynomial, or the 0 of the divisor, which is x plus 1, is x is equal to minus 1. Okay, so now consider the dividend, which is 3x square plus x plus 1. So what happens when we substitute this value, that is x is equal to minus 1 for the dividend? That is, we put for p of x equals 3x square plus x plus 1, we find p of minus 1. So we have 3 into minus 1 square plus, instead of x we put minus 1 plus 1. That is, p of x was 3x square plus x plus 1. So instead of x we are putting minus 1. So we have 3 into, instead of x square we have minus 1 square plus minus 1 plus 1. So minus 1 and 1 will become 0. Minus 1 square is 1. So this is 3 into 1. See, can you see that it is the same as the remainder here? Okay, let us look at one more example. So when we divided p of x by q of x, that is 3x square plus x plus 1 divided by x plus 1, the quotient was 3x minus 2, the remainder was 3. The 0 of the divisor, or the 0 of q of x, here in this case it was x plus 1, is minus 1. And when we substitute that value for p of x, that is p of minus 1, we got the value 3, which is the same as the remainder. Let us look at one more example. So here we are dividing x cube plus 1 by 1 plus x. So the first thing that we do is we write the divisor and the dividend in the descending order of powers. So here we have x cube, there is no x square term, there is no x term. So what do? We have to add 0x square, 0x, then we have the plus 1. Okay, so we look at the first term, we have x cube. So we have to find some expression or some term, so that when we multiply this whole thing by that term, the first product or something into this x should give us x cube. What is that? X square. So x square into x will give us x cube, plus x square into 1 will give us 1x square. So we have x cube plus x square. Okay, now we subtract. So subtracting this becomes minus x cube. Okay, and minus x cube plus x cube becomes 0. This becomes minus x square. Minus x square, 0x square will be minus x square. Now we bring down the 0x. So now we have minus x square. So what into x would give us minus x square? So that is our next question. Okay, so what into x would give us this minus x square? What will give us minus x? So minus x into x will give us minus x square. Minus x into plus 1 will give us minus x. So for subtracting, this becomes plus x square, this becomes plus x, and this, both of these will cancel, they become 0. Now we have plus x and 0x. Alright, so we have 1x. Okay, 1x, 0x, on adding we'll get 1x. So we bring down the 1. So now we have what into x will give us x. Okay, what into x will give us, that is 1, in fact plus 1. So plus 1 into x will be x, plus 1 into 1 will be 1. So the remainder is, in this case, is 0. Okay, so upon dividing x cube plus 1 by x plus 1, the quotient is x square minus x plus 1, and the remainder is 0. So we look at the divisor. The 0 in this case is minus 1. Okay, because when we equate it to 0, x is equal to minus 1 is the 0 of the divisor x plus 1. So now we take the dividend p of x, and now we substitute the 0 of the divisor inside the dividend. So what do we get? Minus 1 cube. Okay, 0x square, these two terms are not there, plus 1. What is minus 1 cube? Minus 1 plus 1, which is 0, which is the same as the remainder. So when we divided x cube plus 1 by x plus 1, the quotient was x square minus x plus 1. The remainder was 0. The 0 of q of x, or the 0 of the divisor, when we substitute that 0 inside the dividend, we get the same value as the remainder. So based on this, we can formulate the theorem known as the remainder theorem. So let p of x be a polynomial of degree greater than or equal to 1. So we took some polynomial of degree greater than or equal to 1. If p of x is divided by a linear polynomial x minus a. So what is a linear polynomial? It is a polynomial of degree 1. So if we are dividing a linear polynomial of degree 1, okay, it can be of the form x minus a, where a is any real number, then the remainder is p of a. So this can be written as x minus minus 1. Okay, so if we are dividing a polynomial of degree greater than or equal to 1, okay, by a linear polynomial of the form x minus a, okay, then the remainder is p of a. So what is the relationship between this a and this x minus a? X is equal to a is the 0 of this x minus a. So what the remainder theorem tells us is, if we take any polynomial of degree greater than or equal to 1, and we are dividing it with a linear polynomial, to find out what the remainder is, we don't have to perform the long division. Okay, all we have to do is find out the 0 of the divisor. Okay, in this case the 0 is minus 1. Okay, and substitute that value inside the dividend. Okay, so if I substitute p of minus 1, I'll get the same remainder as the value of the polynomial p of x at x is equal to minus 1. This is what is meant by the remainder theorem.